right, here's 7-1, day 1. Chapter 7 is going to be split up into 2 smaller tests, by the way. Just like 6, we're going to keep doing that. I think, don't quote me on it, I think the rest of the year with chapter 7 and 8, that we'll keep our tests kind of smaller with fewer learning targets. This one's just going to have 4 on it total. Not so different from 6, but we are getting into fundamental identities. And there's a big list of them. Reciprocal, Pythagorean, quotient, even and odd, and cofunction. Those are typically the ones I would expect that you know. Okay? What we're getting into is basically how, if you have functions or expressions that have trig functions that are a little bit bigger and more complicated, how you work with those to simplify them. That's kind of what today is about, okay? For the most part, and then the last slide has a little bit of a review of just getting trig values of any angle, okay? If you were working on a test, I'd expect that you have this list of identities. They're kind of like all of our rules to go by, if you want to think of them like that, okay? Certainly feels like a lot for one slide here, but it's all of them, the whole chapter. I'm not going to give you any more of them. That's what they are. Now, as far as kind of like going through and verifying that some of these identities are true, like a couple that, off the top of my head here. In class, I'll probably show you that one with a diagram of kind of an arbitrary right triangle. They're not that hard to show, and it's worth doing that. As far as like the step-by-step proof to show these, you guys could handle it. Logically, it's not super complicated. They're a little tricky. I think it would stretch it a little bit, but we'll take a look at it. I think we'll manage. And that one too. Like I'll show you a couple of these. Okay. This I want to just get out there because it comes up a lot. Like you are allowed to rearrange identities. Okay, one of the Pythagorean that's saying that an angle's sine value plus its cosine value squared equal 1. Okay, now if you were to subtract cosine squared from both sides, you would get that. Okay, in a minute I'll rewrite that Pythagorean identity in as many ways as possible. Right now, I'll jump ahead down here and actually say that we've got the first. So if we wanted to use one of these to make a substitution in a trig expression, which we'll get to on the next slide, you could use the original form, which is right here. Or if it was more beneficial to use that form, you could. Okay, you absolutely could do that. Now, I just got to say it because it inevitably always seems to come up. It's like kind of tempting to say, hey, what if we just drop, what if we just drop the squared signs? Not allowed, okay? This right here, not a thing. 1 minus cosine does not equal sine, okay? Don't do that. Yeah, those squared signs have to stay on there, okay? It's kind of a random thought to go with a Pythagorean identity, but it's a common enough mistake that I'm like, all right, as soon as you see these identities, get it out there, right? Just make sure they know that so they know not to do it. All right, I'm going to keep rearranging the original one, right? Sine squared plus cosine squared equals 1. You could also say, if you subtracted sine squared, that cosine squared was equal to 1 minus sine squared. That's true. Okay, it's always allowed to rearrange identities if the algebra behind doing it is legit. Okay, subtracting sine squared from both sides works. Just dropping the squared sign, like I was trying to do in that part that's x'd out, that does not. Oh, if you kept rearranging a little bit, you could say cosine squared theta minus 1 is equal to negative sine squared. That's true. Okay, so my point here is sometimes, if you rearrange the terms, of an identity, that's valid as well. And a fourth and final way, sine squared minus 1 is equal to negative cosine squared. Okay? So you could use like the original or any four of those rearranged. And you'll see both of those come up today. All right. So when you are simplifying trig expressions, it can be a little bit tricky because I can't give you like a nice, easy little checklist to just say, hey, follow this, and it's going to get you where you need to go every time. It doesn't really work like that, but I can give you a list of good things to try that over time you'll get good at with some practice to kind of figure out what the appropriate first step is. Always be aware of factoring, okay? Or you might need to rewrite an identity. That's what I was doing on that other slide. One of those, if you're going to make a substitution, may need to be rewritten. Times you may need a common denominator if you're going to add fractions. These are all things in the examples I have for you today. You'll see them. I know this feels like a lot, and we need to get to a point here pretty quick where it's like, okay, show me what the heck this looks like when you're doing it in a problem. And that's right where we're headed. Ideally, we can get it down to one trig function or one number. That's not always possible. When you're rewriting, you might need to factor again. Right? Always beware of factoring. And you might have more than one term in your answer. Ideally, we get it down to one, but don't think if you have more than one that, oh, I must be wrong. Possibly not. Okay? Okay, that's kind of enough of the background. I'm sure that probably got a little long for you, but yeah. Let's simplify some trig functions. Okay? Sine of b times cotangent of b. The product of those two, I'd like to narrow it down. Like, is there an easier way to write that just as one single trig function? This is typically where I'd take a look at my list of identities. Sine of b, I'd say I don't think there's really anything to do with that, right? The only thing that comes to mind is to write it as, 1 over cosecant as a reciprocal, but I don't think that's what I want to do. Cotangent comes to mind right away. Cosine b over sine of b, right? Cotangent to me was the most obvious place to go ahead and make a substitution with that quotient identity. Once I do it, I see multiplying and dividing by sine of b will cancel, and it will equal cosine of b. Okay, so we did it. Sine times cotangent equals cosine. We took that trig expression and we simplified it. Okay. Here's another one where we can use an identity rearrange to help us out. Okay, on your list on the other slide here, you have 1 plus cotangent squared. It says theta, but I'm just going to call it a. Right? 1 plus cotangent squared is equal to cosecant squared. Okay, now you look down here, and if you subtract 1 from both sides, you would get what is given to you in the problem, right? Cosecant minus 1. Okay, so if I did subtract 1 on that left side, all I would be left with is cotangent of a. Okay, that's basically an example, again, of another Pythagorean identity that you could rearrange. If 1 plus cotangent squared is cosecant squared, well, that means that cosecant squared minus 1 is equal to cotangent squared. All right, tangent of pi over 2 minus theta times secant of theta. Now, right off the bat, I feel like there's potential that I could simplify both of these terms. Okay, what I usually do is I look at my list of identities and kind of think, all right, what fits? What fits? Tangent of pi over 2 minus theta just seems made for cotangent, right? Now, I should have mentioned that list of identities you found on the first slide, if you didn't already have that printed out or copied down on a separate sheet of paper, you would want to do that. As I'm going through these, it might be very helpful that you can access a copy of those identities. Okay, that's a co-function there that says that tangent of pi over 2 minus theta is equal to cotangent. That's another one. If I wanted to draw up a diagram and prove that to you, it wouldn't be that hard. Okay, secant, I'm going to go right away with that too. I could use a reciprocal and say that secant is 1 over cosine. Cotangent is the same thing as cosine over sine. That's the definition of cotangent. Times 1 over cosine. Those cosines will cancel. And it leaves me with that, which I like because it's a single trig function. Use the reciprocal identity, we get to our final answer. That whole thing that we started with could simplify to cosecant. Okay? Really kind of the theme on all of those. If you go back to our list up at the top, I'm rewriting those with identities, okay, which is a big thing. It's kind of like if you got 3 parts of this: factor, add terms together that might need a common denominator, or rewrite with identities. All you saw there was rewriting with identities. Okay, I didn't do any factoring, didn't do any common denominators. Next slide, you'll see that a little bit, but that was all rewriting and substituting with identities. All right, so let's see here. These will have a little bit more kind of going on. Now, come to think of it, I don't think any of these have any factoring. I think that might be like a day 2 thing that you'll start to see me do that a little bit. Do some factoring. These are going to have adding terms together with common denominators. Okay, just make sure the work for these is nice and split before we dive into it. Okay. First term, okay, so just to speak to factoring a little bit, when I say to factor, I see I have 2 terms to this expression. The first is sine of t, and the second is cotangent t times cosine of t. Okay, if I were to factor, I would look and see, do my 2 terms have any trig functions in common? Okay, I'm kind of getting ahead of myself. This is a topic we'll really address in day 2. But I look at this and I see no, right? The first one has sine, the second one has cotangent and cosine. They don't have anything in common, okay? So what I'm going to do is just rewrite sine of t. And again, you've seen a common theme here. Cotangent, I really like to rewrite as cosine over sine, right? Now remember, goal here is to get this down to a single trig function. I'm still multiplying by cotangent of t out there. All right, now I've got sine t plus, if I multiply those 2 together, I have cosine squared t over sine t. All right? It's about the time that if I'm going to write these as a single trig function, I need to get these 2 terms added together. And here's how that would have to work. I need a common denominator, okay? And it's going to have to be sine. So what I can do is I can take my first term and I can multiply by sine of t over sine of t. Totally legal move because anything divided by itself is 1. You'll see here in a minute what this will do. All right, so I've still got that sine of t, and I've still got cosine squared over sine. All right, as I do this, okay, I'm multiplying by 1. That does not change the value of my expression. Now, it's kind of weird to think about value because it's like, value is in a number. We don't have any numbers. I'm like, yeah, I know, we don't. But if we did, right, we could plug in numbers for t. But regardless, even though there's a variable t in there, anything divided by itself is 1, so legal move. when I combine those, I get this. Sine squared, that's coming from sine times sine, all over sine, plus cosine squared over sine. Okay? Common denominator, right? These can be rewritten because they have fractions, but now their denominator is the same. So I can combine them into 1 by putting them all over sine. Now, you see with practice that sometimes when you get it simplified to a certain point that you see a certain identity just jumps out at you. You're probably not there yet because we're just getting into this whole thing, but the top of this fraction just screams for a Pythagorean identity. Okay, sine squared plus cosine squared, that whole top is 1. And using a reciprocal, 1 over sine is cosecant. Now you see a little theme here. I think the last one over here to the right comes out to be cosecant as well. It's completely coincidental. There's no like strong theme that a lot of problems that we'll do will simplify to cosecant, but you actually see 3 of them today that do. It's just a coincidence, okay? You're just as likely to see problems in your homework that will simplify to tangent or cotangent or cosine or whatever. I mean, you saw the first one simplified to cosine and the second one cotangent squared, but that's 2 in a row, and it's actually going to be 3 in a row here because, spoiler alert, this one's going to simplify to cosecant, okay? So here, right, I think it's the way it's written maybe a little more clear that I've got these 2 terms and I need to add them together. Okay, they need a common denominator right away, right? In part C, I kind of checked to see if I could factor them first and then said, nope, wait a minute, can't do it. So now I've got denominators of sine and 1 plus cosine, and here's how you handle that. Here's the first term. I have sine of theta over 1 plus cosine. I am going to multiply that by sine over sine. Totally legit. Anything divided by itself is 1. Okay. The second term is cosine over sine. That also needs to be multiplied, but I need to use the other denominator. The top and the bottom here have to get multiplied by 1 plus cosine over 1 plus cosine. In other words, if you have a situation like this, where you've got 2 different denominators, multiply them by each other, okay? Essentially, my common denominator, once I have these combined, is going to be 1 plus cosine times sine. I'm going to simplify the 2 terms separately first, right? Right now I'm just working on the first term, 1 plus cosine times sine. All right, now on the top I've got sine times sine, so that's going to be sine squared. And then over here I've got sine theta times 1 plus cosine. Now if you compare it to the other denominator, don't be fooled that the order is different. That doesn't matter. You can multiply the terms in whatever order you want. You could even switch them if you wanted to, okay? Now I'm going to basically treat it like this. These 2 terms up here need to get multiplied, but I'm going to basically distribute the cosine over that second term, so we would have cosine theta plus cosine squared. Okay? Now I can combine them all together in one denominator of sine theta, 1 plus cosine. Right? And again, I'm still this is taking a few steps to do, but I'm following the idea that I've got 2 terms that are fractions, and I should get a common denominator and rewrite them together. Right? If you see that that's the case in the problem you have to start, that's the move you want to make. Okay? Now on the top, I've got this. Sine squared plus, I'm going to switch the order of these two terms over here too. I'm going to do cosine squared here, and then just cosine. Again, there's times where hopefully with practice, a certain identity just jumps out at you where you see sine squared plus cosine squared, that whole thing is 1. So the whole top of the fraction is 1 plus cosine. The bottom is sine times 1 plus cosine. Those will both cancel. We get 1 over sine. And again, just a coincidence. For the third problem in a row, it simplifies to cosecant. Just a coincidence. Don't think anything of it. Well, there you go. Those two are a step up. So you got 3 of them that are a little bit more basic, and these are more on the medium side of things. We'll get to a few that are a little bit harder, but they follow, substitute with identities, factor, common denominator, and add the fractions together. These kind of follow our guidelines for what to do. That at some point they both involved, okay, you've got these two terms, one or the both are fractions, get common denominators, and add them together. All right, this is more of a review thing right here. I just wanted to throw in here. Okay, back to evaluating a function. Okay, thought it'd be good for us to just see this again. This is not involving identities. When you make your sketch, make sure you're set up in the appropriate quadrant, okay? I'm going to make sure we're clear. I'm kind of switching gears from what I was doing before. Okay? Kind of switching gears. What I want is, based on the information that I have, to sketch angle U and determine all 6 of U's trig values. Really the other 5, because, I know its secant value is -3 over 2. So I'm going to make my diagram right here. And this is the big piece I wanted to review, is how do you make sure we get in the right quadrant? Secant is negative and tangent's positive. Now, you can see in our little diagram over here, it doesn't mention secant, but just know that it always goes along the same as cosine because they're reciprocals. So if secant is negative, so is cosine. So now what I'm checking in those quadrants is if cosine is negative and tangent's positive, where am I? Right? If cosine is negative and tangent's positive, we are over in quadrant number 3. Okay, and this would be angle U. And I haven't drawn this to scale, but specifically if I marked in this and this, right, so that was right angle, okay, secant is R over X, right, so R would have to be 3, I'll label that, X would be -2. Got a little bit of work to do to get Y, right? Just do that right down here. Y squared plus -2 squared would equal 3 squared, okay? Or that y squared plus 4 would be equal to 9. Not sure if you notice this, but I am running out of room. Now, before I take the square root here, I'm just going to slide this over here. I'm going down for the y value, so I ended up doing it after I did the square root. But I was thinking about it before. Before we did the square root, I knew the answer had to be negative, right? It could go either way, technically, when you take that square root. But that's a really important thing here for y, that it is negative square root 5. We're down in quadrant 3, so x and y both have to be negative. All right? That's really the part I wanted to review, because once you have that, you're typically off to the races, right? I'll just list off all 6, of course, starting with the easiest one, the one I know. And then I love to go over to cosine. That's the easiest one to get. It's negative 2/3 from a reciprocal. Then let's go sine, right? Sine is y over r. That would be negative square root 5 over 3. And then let's go reciprocal. Tell me about cosecant. That would be negative 3 over square root 5, right? And of course, we'll rationalize that. Negative 3 square root 5 over 5. Tangent's y over x, negative square root 5 over negative 2. Negative and a negative would make it positive. Okay. Oh, and then I'll just throw cotangent down here. Cotangent of u would be the reciprocal of negative 2 over negative square root 5, right? Right off the bat, I just say drop the negatives. And then I'll rationalize that. 2 square root 5 over 5. Okay? That's all for day 1. Good work. We made it. Short lesson for day 2. This whole idea of factoring. And then doing some identities based off that, or simplifying some expressions based off of factoring. I want to take a look at that.